So welcome back, and today we are starting a new topic, which is actually algebraic equations, right? What's really important to remember is that if we can't do the basic algebra, then we're going to struggle with algebraic equations. But the good news is we're going to get more opportunity to practice our basic algebra as we go. Right, so let's dive straight in, and we're obviously on page 1 of our workbook, and significantly there's a scale there, all right? And a scale is a really powerful metaphor or idea for teaching equations, okay? So the equal sign in an equation represents balance. The two sides are balanced, okay? Right, so we're going to dive straight in, and we're going to now look at some equations, okay? And we're going to ask you to see if you can fill in what numbers should we put in the box to make these statements true, all right? We've done this sort of thing before. You might even have done it at primary school, okay? And we're going to try and work out what number must go in each box to make this thing work, all right? So we're going to ask you to pause the video and just try those questions and then let it play again and see how you went. Okay, so 2 plus what gives us 7? I think most of us are going to be okay with that. 2 plus 5 gives us 7. 5 subtract what gives us -1? 5 subtract 6. 4 times what gives us 24? 4 times 6 gives us 24. 2 times what plus 1 gives us 9. Right, now if we think about this stuff that I've underlined here must come to 8, because 8 plus 1 is 9. So 2 times what gives us 8, and the answer is 4. 3 times what minus 2 will give us 31, right? So before we minus 2, we need to have 33 in this underlined piece. So 3 times what gives us 33? And the answer is 11. This is really nice thinking stuff. We're using our brains. Okay. Now, in maths, we tend not to use a box. We tend to use a variable. All right. So we use a variable to represent the value that we're trying to find, the unknown value that we're trying to find. So this is very similar. These are similar questions, but we want you to see if can you work out what x equals in each of these. Pause the video, try them and let it play again. Okay, so this first one. 2x equals 8. Now remember what 2x means. It means 2 times x. 2 times what gives us 8? X must be 4. X plus 5 gives us 14. What must x be? What must we add 5 to get 14? And the answer is 9. Notice we're writing our answer underneath and we're underlining our answer. 13 minus x equals 9. 13 subtracts some number to get 9. Well, x must be 4. That number must be 4. X divided by 2 is 12. Right, what number divides by 2 to give us 12? X must be 24. All right, 2 times x plus 3 must be 13. All right, now obviously this piece over here must be 10. All right, so remember 2x means 2 times x. So what must x be if that green underlined stuff, all this stuff must come to 10? Well, x must be 5. Does it make sense? It always makes sense. Okay, right. And the last one, 4x minus 1 is 19. So 4x subtract 1 is 19. That means that this piece must actually be 20, mustn't it? So that when we subtract 1, we get 19. So 4 times something must be 20. 4 times x must be 20. So what must x be? X must be 5. Okay. All right. Pendula ikasi. Turn over the page and let's see where we're going next. All right. Okay. This equation, 3x plus 2 equals 20. All right, let's think about solving this one. Okay, what would x have to be here? 3 times something plus 2 is 20. So this yellow stuff must be 18. All right? Okay, so in fact we have an answer. 3 times something is 18, so x must be 6. All right, so this equation has a solution. Solution, x equals 6. This is also called a root. Okay, we don't really call them roots until a bit later on, but later on we're going to call them roots. Okay, all right. All right, I realized I've written the word x, I've written the x equals 6 later on. So it just has a solution, also called a root, of x equals 6, since 6 is the only value which makes both sides equal when substituted for x. Right, now, solving an equation is a little bit like unwrapping a present. We all love unwrapping presents. Imagine we unwrapping a present which has been wrapped with loads of different layers of wrapping paper. Maybe the first is just wrapped with newspaper, and then outside with red paper, and then outside that with green paper. So when we unwrap the present, we're going to undo it in the reverse order in which it was wrapped. Okay, the first layer of paper to come off is the one which went on last. And the last one to come off is the one which went on first. And so solving an equation is similar in that we're trying to undo what has happened to our variable. If we look at this, 3x plus 2, what is happening to x? In what order? All right, it's being multiplied by 3, and then we are adding 2. Okay, in that order, it's being multiplied by 3, and then we are adding 2. Now, if we want to undo that, we must undo it to unwrap it. If it's a present, we're unwrapping it. We're going to undo it backwards in the reverse order. So, how do we undo adding 2? We're going to subtract 2. How do we undo multiplying by 3? We're going to divide by 3. Okay. All right, so we are using this idea of undo operations. They're actually called inverse operations, all right? Okay, an undo operation just undoes, okay? So the undoing of adding 3 is subtracting 3. Okay, right, now let's write down, let's pause the video and see if you can write down the undo or inverse operations for each of these ones in the table here. Okay, adding 6 to a number, subtracting 6. We can check this using any number, okay? Subtracting 6. What an undo operation should do is take us back to where we were, all right? It's a little bit like putting on a jersey, taking off a jersey, all right? You're back to where you were. So let's take a number, for example, 3. If we add 6, we get to 9. If we subtract 6, we get back to 3. Dividing a number by minus 3, multiplying by minus 3. Halving a number. What's the undoing of halving a number? That's right, doubling. Or multiplying by 2. You can write doubling or you could write multiplying by 2. But let's just think about it. If you've got 12 and you halve it, you get to 6. If you double 6, you get back to 12. Square rooting a number. How do we undo square rooting a number? So in other words, if we've got a number like 25 and we square root it, we get 5. What mathematically must we do to get back from 5 to 25? That's right, we must square. Okay, squaring and square rooting are undo operations. Cubing a number, cube rooting. Subtracting 7 from a number, adding 7. And lastly, multiplying a number by a half all right, dividing by a half. Let's write it out. Dividing by a half. Okay, now when we solve an equation, we're going to work backwards, and that's what we spoke about, the sort of the present idea. Okay, so let's have a look at this. We've got this equation 3x plus 2 equals 20. Right, so let's look at what happens to x. It gets multiplied by 3. And when we multiply it by 3, we actually get 3x. Then what happens? Well, then we add 2. And you might remember last term we did quite a lot of these sort of flow diagrams in preparation for this. Okay, add 2. And so we get 3x plus 2. And we end up with 20. Now, when we, sorry, this add 2, I've written it up there. I didn't actually want to write it there. I wanted to write it here as the sort of the operation to get from 3x to 3x plus 2, we add 2. Right, now, when we solve an equation, we're actually going to go backwards. All right, so we've got 20. Now, so 20 is here. Okay, 3x plus 2 is the same as 20. All right, now, that's what the equation is saying there. 3x plus 2 is the same as 20. Now, we're going to go backwards. What's the undoing of adding 2? It's minusing 2. Now, if we minus 2 from 20, we get to 18. All right. So 3x is actually the same as 18. And that's what we did earlier in our head. Right? How do we undo timesing by 3? That's right. We divide by 3. What's 18 divided by 3? 6. Okay. And there's our answer. Now, we're not going to need to draw these flow diagrams, but let's just think about this. What we're going to do here, we're going to subtract 2 from both sides of this equation. So 3x equals 20 minus 2. What we've done, we've subtracted 3 from both sides of this equation. At the start of the lesson, we spoke about a scale. All right, and if a scale is balanced and we do the same thing to both sides, it will remain balanced. If we add 5 to both sides, it will remain balanced. If we subtract 4 from both sides, it will remain balanced. If we double what's on both sides, it will remain balanced. But if we add 3 to one side and 2 to the other, it will not be balanced. Okay, so what we've done from this line to this line, we've subtracted 2 from both sides. Not from one side, from both sides. The plus 2 that was there is no longer there, we've subtracted it. But to keep it balanced, we've subtracted it from the right-hand side as well. Let's just work out what is 20 minus 2. 20 minus 2 is 18. Right, now what does 3x means? It means 3 times x. I don't want 3 times x. I just want 1 times x. Okay, do I need to write that 1? No, I don't. Okay, just x. What must I do to get rid of timesing by 3? I must divide by 3. So if I divide 3x by 3, I just get to x. Cordwa, but I can't just divide by 3 on one side. I'm going to destroy the balance. I've got to divide by 3 on both sides. This is going to be 18 divided by 3. Right, and there's my answer. 18 divided by 3 is 6. Okay. Right, so, Penduli Ikasi. We are going to use a scale idea. All right, but before we do that, just something that we want to emphasize. Once we've got our answer, we can always check, does our answer work? In other words, if we put our answer back into the equation, instead of x, we put 6. Do we get 20? And let's just look at that. What is 3 times 6? It's 18 plus 2. Yes, we get 20 equals 20. 6 is the only number that will make that work. 6 is the solution to this equation. Right, 6 is the value of x that makes it work. So we can always check, and therefore we know that we are right. Okay, now we've spoken about the idea of a scale. Okay, we're going to do the first 4 together. All right, so we're trying to find x here. We're just trying to get x on its own. At the moment, x is having 3 added to it. let's subtract 3. All right, just to leave us with x. But remember this. If we subtract 3 from one side, we must subtract it from the other side. So our answer is going to be x is 11 minus 3. All right, our final answer is going to be x equals 8. We have subtracted 3 from both sides. And when we subtract 3 from both sides, we preserve, we keep the balance. Okay, all right. Don't forget, before we go on, let's just check. If we put this answer back in here, 8 plus 3, 11 equals 11. This is right. We've got it right. Okay, now let's look at this next one. This time, we've got x subtract 8 equals 11. How can we undo subtracting 8? What can we do? We can add 8, all right? I'm actually going to write it in this time. I'm going to write it in over here. I don't normally do this, okay? What I've done is I've added 8 to the left-hand side, so I must add 8 to the right-hand side. Okay, sorry, that's a dreadful 8. Let me just have another go at that 8. 11 plus 8. Okay, now on this side, we've actually got just x. All right, because negative 8 and 8, they cancel one another out. And so our final answer is just 11 plus 8 is 19. Before we go on, let's just check that answer. All right, if x is 19, 19 minus 8, 11 equals 11. Yeah, that's right. Okay, let's do another one. All right, what's happening to x here? It's being multiplied by 2. What should I do to get x on its own? I should divide by 2. On which side should I divide by 2? On both sides. Have to divide on both sides. All right, so my final answer here is actually going to be 12 divided by 2. We've divided both sides by 2. My final answer is x equals 6. Don't forget, before we move on, let's check that answer. 2x means 2 times x. 2 times 6, 12 equals 12. Ha! Okay, what's happening to x over here? Well, it's being divided by 3. How do we undo dividing by 3? That's right, we times by 3. If we times x divided by 3, okay, and I want to show you what we're meaning here. We're going to times by 3, all right? Remember 3 is 3 over 1. What actually happens here is that these 3's divide out. Some teachers say cancel. I don't like the word cancel because it suggests that nothing's left. They divide out. And all we are left with is x. Right. X was being divided by 3, so we're now timesing by 3, we get back to x. Those are undo operations. But, and this is the big but, we cannot just multiply one side by 3. We've got to multiply both sides by 3 to keep the scale balanced. Don't forget the picture of the scale in your mind the whole time. Have a picture of a scale in your mind. Okay. The school that I teach at is called Michael House, and on our badge we've actually got scales. Okay, not because of the maths, but it is a useful reminder. Okay, now if we multiply the left hand side by 3, we must multiply the right hand side by 3, and we get 10 times 3, we get 30. Let's just check that answer. 30 divided by 3, we get 10 equals 10. It's definitely right. Okay, now we're going to do 2 more before we stop, and then we want you to practice some. So let's have a look at what's happening here. 2x minus 1 is 9. All right. I don't want this minus 1 here. All right. I'm trying to get back to x. What could I do to both sides to get rid of that minus 1? Hala, I could add 1 to both sides. Okay, if I add 1, it's gone. But I must add 1 here as well. Right. It doesn't matter to us at the moment if you write 2x equals 9 plus 1 and then simplify it. All right, now, what's happening to x? It's being times by 2. How do I undo timesing by 2? That's right. I divide by 2. On which side? On both sides. 10 divided by 2. 10 divided by 2 is actually 5. All right, now let's check this answer because this one's a little bit more complicated. The question says 2x minus 1. Now remember, 2x means 2 times x. Remember in the last section of the last topic we were substituting in? That's exactly what we're going to do now. If we put x in there, we don't get 25, 5, we get 2 times 5. 2x means 2 times x. 2 times 5. 2 times 5 is 10. 10 minus 1 is 9, and the right hand side is 9. This is definitely correct. Okay. All right. Now, 3x plus 1 equals 19. So x is being multiplied by 3, and then we are adding 1. Now, we want to undo that. So let's first subtract 1. From which side? Ha ha, yeah, I hear you. From both sides. Okay. We have subtracted 1 from both sides. And I want to ask you now, is this better or worse? Is this simpler or more complicated than it was? I think it's simpler. Okay? Now, what does 3x mean? It means 3 times. How do we undo timesing by 3? We divide by 3. On which side? On both sides. Our final answer is 6. Before we finish this lesson, let's check this answer, okay? Let's substitute it back in. Remember, 3x means 3 times x. 3 times 6, 18, plus 1, 19. 19 equals 19. Halala. Right, now, before the next lesson, we want you to try the rest of the questions on page 16, and we'll look forward to going over them with you next time. Have a great day, everyone. Enjoy.